Welcome back, Algebra students. For this next set of problems, we are allowed to use a graphing calculator or program to solve them, and I'm going to show you how to do that. So we're going to use GeoGebra, and what we're going to do is we're just going to punch in these equations as they are exactly here to find the zeros. Now, here's the interesting thing about finding the zeros. What we're looking for is not the value that we get when we plug 0 in for x. When we plug 0 in for x, we're going to get some y value. Maybe that y value is at the vertex like it was in letter C. Maybe that y value is just somewhere on the parabola like it was in letters A and B. But there's going to be some y value when we plug 0 in for x. That's the y-intercept of the parabola. However, we're not looking for that. We're looking for the values of x for which y is 0. That's what it means for the zeros of a parabola. And there's a very specific thing we're looking for in the graph. Now, again, I'm going to mention this. There's a really creative and interesting way to do this without graphing that we are going to be doing, and I think you're going to like it when we do it. It's really cool that we can find the zeros of the parabola without a graph. We're going to be using graphs in this lesson. Anytime you see the graphing calculator, you're allowed to. All right, let's get started with this. First, I'm going to punch in the equation y equals x squared plus 10x plus 25, exactly like that. Y equals x squared plus 10, plus 10x plus 25, okay? Now, remember, any graph can have 1, 2, or no zeros, okay? It's going to have just one zero if it just barely kisses the x-axis. It's going to have 2 zeros if it actually crosses the x-axis. And if it never crosses the x-axis, it's actually not going to have any zeros. What I can do in this graph is click right here, and I find out that when I click right here on the graph, it actually has a root that just barely touches the x-axis. So one of its zeros is at -5. All right. So the answer for letter D is just -5. And I figured that out by graphing and inspecting the graph. What happens if I plug in -5 for x? Let's just find out. -5 squared is 25. Plus 10 times -5 is -50. Okay, so 25 minus 50 is -25 plus 25 is 0. And that's the only number that will give me a 0 from this graph because it just barely touches the x-axis. All right, let's take a look at letter E. 3x squared minus 21x plus 30. So we're going to enter 3x squared. Oh, y equals, can't forget the y equals. Y equals 3x squared minus, make sure our minus is on the outer level. It's not in the exponent. 21x, and then it's going to be plus 30. So we're going to include that here. And this is our next graph. Notice that this one crosses the x-axis, so it actually has 2 zeros. We can find those zeros by simply clicking on the graph. We see that one of our roots or zeros is at 2. The other one is at 5. So what I would do for this one is I'd say that the zeros are 2 and 5. And let's just plug those in and see what happens. 3 times 2 squared is 3 times 4, which is 12. Minus 21 times 2, well, that's 12 minus 42 is negative 30. Negative 30 plus 30 is 0. Does it work if I plug in 5 too? Let's find out. Plug in 5, I have 3 times 5 squared is 75. Minus 21 times 5 is 110. So 3 times 25 is 75. Oh, wait, hold on. 21 times 5 is 105. So 75 minus 105 is negative 30. Plus 30 is 0. So this one also works out. And then lastly, I have y equals -1/2 x minus 1. So another one we're just going to plug into the calculator. Y equals -1/2 x squared minus 1. Oh, look at this one. Let me just make sure we got this right. -1/2 x squared minus 1. It never crosses the x-axis. So therefore, because it doesn't cross the x-axis, there are no zeros. Okay, so here we had an example of each type. And then lastly, the height of a soccer ball that is kicked can be modeled by the function f of x, or y, equals -8x squared plus 24x, where x is the time in seconds after it's kicked. Find the time it takes for the ball to reach its maximum height. Now, for this one, it doesn't show a picture of a graphing calculator. So what I should do is use the axis of symmetry equation, -b over 2a, to figure out where it's axis of symmetry is, and that axis of symmetry is at the time it takes to reach its maximum height. So for this, I'm going to use negative b over 2a. In this equation, b is the coefficient of the x term. So this would be negative b over 2a, negative 24 over 2 times whatever a is. A is a coefficient of the first term, so it'd be 2 times negative 8. Okay, this is the same as negative 24 over negative 16, because 2 times negative 8 is negative 16. Negative 24 over negative 16 simplifies. Let's see, I can divide 24 by 8. That becomes 3 over 16 divided by 8 is 2. 3 over 2, or 1.5. Okay, so let's just double check. And that's 1.5 seconds. After 1.5 seconds, the soccer ball reaches its maximum height in letter G. Let's just see if we get that same answer on a calculator. Here I've graphed the equation, and I look, this is the height of the soccer ball over time. What is the time at this maximum height? And if I click to find it, let's see, there we are, 1.5 seconds. And I see that this also tells me the ball goes 18 feet into the air. Okay, 1.5 seconds is the correct answer, though, because it was just asking for time. There it is. And that is how you graph quadratic functions.